Hello, this is Rahul from Learning Simplified. In this video, we will look at overflow in signed numbers. So let's get started. In signed numbers, let us consider an example. Let us consider an operation as -7 plus -7, which gives -14. Now how do we write -7? We first write plus 7. We first write plus 7. In signed numbers, the first bit is 0 because we are dealing with signed numbers. Signed numbers, the first bit is 0, which represents it is a positive number, and 7 as 1, 1 and 1. Now we write -7 as, we take the 2's complement of this number, which is 1, 0, 0, 1. This is the value of -7. Now we perform the calculation as 0, 1, 1. Oops, this is -7, right? Yeah. 1, 0, 0, 1, 1, 0, 0, 1. 1 plus 1 is 0. We carry a 1 forward. 0 plus 0 is 0. Plus 1 is 1. 0 plus 0 is 0. 1 plus 1 is 0. We got a carry. We got a carry here. This is a carry out. But we want the number -14. This is not -14. Let's check if the 2's complement of this number is -14 or not. We write 0 as it is, 1 as it is, 1, 1. What is this? This is 8, 4 and 2. 8 plus 4 is 12. 12 plus 2 is 14. We got plus 14 if we perform 2's complement. But why do we perform 2's complement on a positive number? We have 0 as MSB. So the correct result is we have to copy this one and append it here. That is 1, 0, 0, 1, 0. This is the required answer, but our processor is capable of storing only 4 bits in its register, and this is lost. We have lost this. So there is a need to detect an overflow. Let us check whether this is -14 or not. How do we get a -14? First write the minus symbol and then find 2's complement of this number, which is 0, 1, 1, 1, 0. What is this number? This number is 8 plus 4 plus 2, 14. Yes, this is the right number. So there is an overflow here. Now let us consider another example. After this second example, I will summarize how to find an overflow in signed numbers. The next example is +6 plus 5 must give 11. How do we represent +6 in signed numbers of 4-bit? 0, 1, 1, 0, and +5 as 0, 1, 0, 1. 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 1 is 0. We carry a 1 forward, and 1 plus 0 is 1. This is the answer. But wait, we have got a negative value here. The MSB bit is 1, which means we have a negative value, and there is an overflow here because we can't represent 11 using only 4 bits in 2's complement signed representation, because what is the range of n bit binary number in 2's complement representation? As we have seen, it is from -2 power n minus 1 to plus 2 power n minus 1 minus 1, and using 4-bit register, we can represent the numbers from -8 to +7. This is the range we can represent using 4 bits, but 11 is out of the range. See, 11 is not in the range, and here -14 is also not in the range. So what can we conclude with this observation, with these examples, is when you add two negative numbers and the result, what is the result? Only these 4 numbers, because a register can hold 4 numbers in our example. If it is 8-bit register, then 8 bits. If it is a 16-bit register, then consider 16 bits. But for now, this is a 4-bit register. We are adding 2 negative numbers and we are getting a positive number as a result. Then an overflow has occurred. In this case, we are adding 2 positive numbers and we are getting a negative number as a result. See, there is a 1 in the MSB. So we can conclude from these observations as, note, the note is 1. An overflow has occurred if the sum of 2 positive numbers is negative, then an overflow has occurred. And if the sum of 2 negative numbers is positive, then also we say an overflow has occurred. Alright, did you get what I am saying? Here we are adding 2 negative numbers and we get a positive result. Here we add 2 positive numbers and we get a negative result. There is one more shortcut technique to detect an overflow. That is, if a carry in, consider only this column. If a carry in from the right side to this column is equal to carry out, then we say there is no overflow. But the carry in and carry out are different, then we say an overflow has occurred. So here the carry in, C in equal to C in, we don't have any carry in here, so we can consider it as 0. We have a carry out, C out is 1. So both are different, hence we say there is an overflow. In this case, consider this column carry in is, we have a 1 from the right side, we have a 1, and carry out, we don't have any carry out, so we can consider 0 as a carry out. C out is 0, so there an overflow has occurred. Now let us see another example where we get a carry out but overflow doesn't occur. Now we add 2 numbers, -6 and -13, which is -19. Now we consider an 8-bit register. To get -6, we first write +6 as in 8 bits as 1 2 3 4 0 1 1 0, and we get -6 as Start from the right. 0, 1, 0, 1, 2, 3, 4, 5. This is minus 6, and we write plus 13 as 1, 2, 3, 4. 8 plus 4 is 12, plus 1 is 13, and minus 13 as 1, 1, 0, 0, 1, 1, 1, 1. 1, 2, 3, 4, 5, 6, 7, 8. Yes, this is minus 13. Now we perform the calculation as what is minus 6? 1, 1, 1, 1, 1, 0, 1, 0. And minus 13 is 1, 1, 1, 1, 0, 0, 1, 1. We add 0 plus 1, 1, 1 plus 1 is 0, we carry a 1 forward, 1 plus 0 is 1, 1 plus 0 is a 1, 1 plus 1 is a 0, and we carry a 1 forward, 1 plus 1 plus 1, 1, carry 1 forward, this is also 1, carry a 1 forward, this is also 1, carry a 1. But people get confused. We have got a carry out forward here, and this is an overflow has occurred. Remember, if we get a 1 in unsigned arithmetic, then an overflow has occurred, but this is signed number arithmetic. So let us consider carry in. Let us consider what is carry in. C in for this column, C in for this column is 1, C out for this column is 1. So both C in and C out are equal, so no overflow has occurred. We can also say that we are adding two negative numbers. These are negative numbers because they have 1 in the MSB position, and we got a negative number because we have a 1 in the MSB position. Even if we ignore this carry, there is no problem, because if we write a 1 here and another one here, another one here, then it doesn't make any sense or any change. Even if we remove this one or this one, it doesn't make any sense, because in negative numbers, if we extend the sign bit any number of times to the left, then the number doesn't change, it remains the same. So what is the required number? Did we get the minus 19 as did we get the minus 19 or not? Let us check. Minus, we take the 2's complement of this. Start from right. 1, 1, 0, 0, 1, 0, 0, 0. What is this number? Let's write the weights. This is 1, 2, 4, 8, 16. Ignore these because all these are zeros. So 16 plus 2 is 18, 18 plus 1 is 19, minus 19. We got minus 19 back. So I want to conclude this video. Remember these things. If we add two negative numbers and the result is negative, then no overflow has occurred. If we add two negative numbers and the result is a positive number, then an overflow has occurred. Alright, or if carry in bit and carry out bit are different, then an overflow has occurred. If carry in and carry out both are same, then no overflow has occurred. Try to practice as many problems as possible. Take your own examples, whatever comes to your mind. Suppose say minus 69 and plus 72, and represent these numbers in signed numbers and perform, and plus 128, plus 46, and like that. Perform as many examples as possible for your own convenience. So that's all for this video, guys. I hope you have enjoyed the video. See you next time. Until then, happy learning.